Hello everyone, welcome you all for the next lecture of SQL database. This is lecture number 3, model number 1, and topic is types of database. Before that, we have learned in lecture 1, we have seen the overview of the syllabus of the course SQL database, where we have seen the contents of this particular course. In the lecture 2, we have learned the introduction of database, means what is a database, what is the definition of database, history of database, importance of database. Everything we have learned in the lecture number. Now in today's lecture, lecture number 3, we will see what type of databases are there. That's called types of database. So let's start now. So outlines means we will see one by one all types of database. Okay. Let's see the chart. This is the chart for types of database. Database can be centralized database, distributed database, NoSQL database, relational database, cloud database, network database, object-oriented database, hierarchical database. There is some spelling mistake, like in base, A is missing. So please, I'm sorry for that. So this is the chart of types of database: centralized database, distributed database, NoSQL database, relational database, cloud database, network database, object-oriented, hierarchical database. So we will see the explanation of all type of database by. So first database is centralized database. Okay, first database centralized. By the term, it is very much clear. Centralized means everything is at the same. Okay, means there are some department like that. This is department 1, this is department 2, this is department 3, this is department 4, this is department 5. We were having a center hub which is having the details of all this sub-department. This was centralized. You know the meaning of centralized database system? All the data is stored at centralized system, center of everything. Okay? Like a hub and node relation like this. This is your centers. So in centralized data system, it stores data at the central level. So suppose a company have multiple branches. So we'll have a centralized system where we'll have the details of all the branches. Okay. So centralized means one side, one. Okay. Many to one. You can understand like that. Many to one. So only one main hub is there. One main center is there. That is the centralized database system. Okay. Centralized means everything is stored at the central level, not at this at different level. Everything is stored at a central level. Okay. If centralized system is there, then there should be some authentication. Authentication is for the security purpose. Authentication is for the security purpose. So it contains the authentication process to access the data. Okay. Means everyone cannot access the data. It depends on to whom we have given the permission. Okay. Those have received the permission, they would have some credential, like some login ID will be there, some password will be there. Okay. So some authentication signature will be there for login or for accessing this particular data. Everyone cannot access this data because it's a very secure data. Okay, because it contains the information of every branch, every location. So it contains the authentication process to access the data. Okay. For example, central library in the university. Or central library in the university means the whole university, the one library. So that is called centralized system. Okay. So centralized database means store the data at centralized level. And it contains the authentication process if you want to access the data. Example, central library. This is type 1. Type 2 is distributed databases. Now, in the centralized, everything is central. But in distributed data system, data is distributed among different database systems of an organization. And this is connected via communication. Data is distributed. Data is distributed among different database system of the organization, and these are connected via communication link. Okay. For example, for a university or for the college, there is a examination department. So one is distributed system for examination. Okay, one is admission department. So one distributed system for the admission. There is one accounts department. So one distributed system for the accounts level. Okay, one is a store department. That is distributed system for the store department. And these are connected through some communications links. Okay? These are connected through some communication links. This is called the distributed. This is called the distributed database. Again, listen carefully. A distributed means it is distributed at different levels. Okay, this is for example for college. This will be one for the examination department, one for admin department, one for accounts department, one for store department. Okay, so different departments are there. So different databases are there. These databases are called distributed database. These databases are called distributed because we are not having at central level. We are having at different level. Okay? And these are connected through some link. Those links are called communication links. These are connected through some link. Those are called communication links. Now, this distributed database again divided into two categories. Distributed database again divided into categories. One is homogeneous, one is heterogeneous. Homo means similar type, hetero means different. Okay, if you remember the meaning, homo means same type. Okay, so those database system which execute on same operating system and use same application process and carry the same hardware, that's called homogeneous distributed database. Okay. Suppose this store department and admin department, both are using same system, same hardware, same printer, same PC, same operating system. Okay, so but database is different. This is for admin, this is for store, but everything is similar. That is called homogeneous distributed database. Those database systems which execute on same OS operating system. Okay, same application process. Methods are same hardware devices. That's called homogeneous distributed database. Heterogeneous means those database which execute different operating system under different application and carries different hardware device. Okay, that is called heterogeneous. Again, listen. Those database systems which execute on different operating system under different application processor and carries different hardware devices are called heterogeneous distributed database. For example, Apache, Cassandra, HBase, Ignite, etc. Okay, so you got it. The first was centralized, everything was at central level. Second is distributed, everything is at distributed. And for different sections, different database. That is distributed database. Homogeneous, share same operating system, same application process, same pattern, and same hardware. Hetero, everything is different. Okay, so this is distributed database. Second. Next is third one is relational database. Okay, relational database. And by the name you can understand the relation means relations. Relational means relation. It is based on some relation. And relational database always in the form of table. Okay, relational database is always the form of table. You know in Microsoft Excel how table is split in table. This is your table. In table there are some rows and some columns. This is your table. And table is called a relation. This is table that is called relation because it is having relation between rows and columns. These are rows, rows 1, rows 2, rows 3, rows 4. And these are columns, column 1, column 2, column 3, column 4, column 5. All the columns are called attributes, means title, what we are going to store, attribute. All the columns are attribute. All the rows are called tuple. Okay. And this table is called relation. So relation database means everything is stored in the form of table. Everything is stored in the form of, sorry. Hmm. Everything is in the form of table. Relational database means database in the form of relations. Database in the form of relation. Relation is table. So here, whatever the information is stored in the form of tables. Okay. For example, MySQL and MySQL server, for example. Got it? First, we have learned centralized, that is information stored at the central. And we have learned distributed, means for different sections. Third is relational, means the database in the form of tables. Okay. Next is NoSQL database. Okay. NoSQL database means it is used for storing a wide range of data sets. Means we are having a multiple data, a lot of data. Okay. So for handling a wide range of data set, we use NoSQL database. Here, data stores not only in tabular form, but in several different ways. In this relational database, everything is stored in the form of tables. But here, not only table form, but the different forms are also used for storing the data. Because we are having a lot of data, wide range of data. So there are four types of SQL. Okay. Now see, type one is key value storage. Key value storage means it stores the item as a key. It stores the single item as a key. Key is an attribute name holding its value together. Okay, like for example, we want to create a table of student. And we have created the table like ID, name, age, address. Okay, so these all are columns. The student ID, student name, age, address. These are the attributes. These are the attributes. If I enter the values, these will be value. Like 1, 2, 3. The name is Ram. The age is 18. Address is suppose Mumbai. These are values. So it's called key value storage. Means it stores every single item as a key. Means ID is a key and value is 1. Name is a key and value is Ram. Name age is a key, value is 18. Address is a key and value is Mumbai. This is called key value storage. This is called key values storage. Got it? Next is document oriented database. Document oriented database, here it is used to store data as JSON like document. JSON is J for JavaScript, O for object, and for notation. JavaScript object notation, just like we store the data in the JavaScript, same format here, data is stored. Database is created. Key value is like a tabular form, but document oriented means it's like a document, like in Word file, we can say. So here data is stored as a script, as a JSON script document. Okay. The third type is graph database. Here the data is stored in the form of graph. Here data is stored in the form of graph. Like if you say like graph chart, in 99 we have so much sale, in 2000 the sale increases, in 2001 it again decreases, in 2005 this is like it is database only year wise. Okay. In 2000 like this, in 21 like this, in 22 like this, in 23 like this. This is database, clearly database. So this is a database in the form of graph. So if we want to store the data in graph format, it's called graph database. Now, white column stores here data is stored in large columns together instead of storing in rows. Generally, we store in rows the data of what investment, but for white, then we store in the form of white columns. Got it? Okay. So, see, in NoSQL means if we have a lot of data, we have lots of data. Okay, then we cannot store it in particular tabular format. We can store according to the condition. So NoSQL database means storing a wide range of data sets. Means we have to handle a lots of data. Then a simple tabular form is not sufficient, and we have to store the data according to the particular type of data. The four types of NoSQL. If you want to store in the form of key value, then tabular form is required. If you want to store it like a document, then it's called document-oriented database. If you want to store data in graph format, then it's called graph database. Or if you want to store that information in large column, then it's called wide column store. That is NoSQL database. Next is next type is cloud database. Okay, cloud database. Cloud, cloud is like which is not in our hand. We can't touch like that. Similarly, here cloud means virtual environment. Virtual environment means it's not a real environment. It's a virtually created, imaginary created like that. So data is stored in a virtual environment and executes over the cloud computing platform. Okay. For examples, like here AWS, Microsoft Azure, Google Cloud SQL. Getting my point? Okay. See here in cloud means it's a virtually created environment. Virtually created environment. Data is stored in virtually created environment. Cloud means virtually data is stored. Okay. So now in the current technology, current demand, clouds are at the height. There's a lot of importance of cloud. Data is stored in virtual environment and executes over the cloud computing platform only. Okay. AWS like Amazon Web Services, Microsoft Azure, Google Cloud, these are all are the examples. So here data is stored in virtual environment. Data is stored in virtual environment and execute over the cloud system, cloud platform. Our next type of database is object-oriented database. Object-oriented database means here, here we use object-based database. Hosting data database system. Objects means there are some classes and there are objects. Object-oriented means it's a class-based objects. Here data is represented and stored as objects. Here data is represented and stored as objects. Like I'm talking about, suppose, for example, I'm talking about the animal. Okay, this is a class. In animal, there can be dog, there can be cat, there can be rat, or there can be lion, there can be tiger, there can be dinosaurs. These are different objects. Got it? This is related to OOPS. The object-oriented databases is used the object-based database. There are various types of objects. Object-oriented database uses the object-based data model approach for storing data in database system. So here, whatever data is represented and stored in the form of objects. Here, the data is represented and stored as in the form of objects. That is called object-oriented database. Okay. Next is hierarchical databases. Hierarchical database. Hierarchical stores data in the form of parent-children relationship nodes. Here, data is stored in the form of parent-children relationship. So what is parent-child relationship? From top to bottom nodes, right? See, let's getting in the 3D. See, suppose this is parents. They are having sons, and sons are having grandsons. Like that, this is for hierarchical. For example, there is a principal, okay, for tracking the performance of any student. She will call the HODs, she or he. And HOD will call the class teacher. Class teacher will call the subject teacher. different subject teacher to understand the behavior of particular child. This is called the hierarchical model. This is called the hierarchical model. Means if you want to check the performance of particular child of particular class, okay. So first, what the principal will call the HOD of the particular department or head of the department or the class coordinator of the class. Okay. Now it will call the class teacher of particular class. The class teacher will call the subject teachers of different subject teachers of that particular child, because a child can be good at one subject and bad at one subject. So this is called hierarchical model. Means from principal to HOD, HOD to class teacher to subject teacher. This is hierarchical. This is like a parent-child relationship. This is like a parent-child relation. Very good. Understood? Stores data in the form of parent-child relations. Parent, sorry. Stores data in the form of parent-children relationship nodes. These are various nodes. Okay? Data gets stored in the form of records that are connected via links. Means the principal to HOD there is a link, HOD to class teacher there is a link, class teacher subject is a link. Getting my point? Means for HOD, principal is a parent and HOD is a child. And for this class teacher, HOD is a parent, it's a grandparent, and this is a child. And for the class teachers, these are the child. This is called parent-child relationship. This is called parent-child relationship. Getting my point? Data gets stored in the form of records that are connected via links. All records are connected by links. These are links between principal, HOD, child, class teacher, subject teacher. So these are connected via links. Each child record in the tree will contain only one parent. On the other hand, each parent record can have multiple child. See, here in the, if you see between principal and HOD, one parent, one child. Okay. Between HOD and class teacher, one parent, one child. For class teacher and subject teachers, one parent but different childs. Okay. So parent will be always a one. Parent will always be a one, but this child can be multiple. Getting my point? For HOD, parent is principal. For class teacher, parent is HOD. For subject teachers, parent is class teacher. But for principal, HOD one, or it can be multiple HODs for multiple branches, HOD of computer, HOD of electronics, HOD of mechanical. But principal will always be a one for a whole college. But HODs will be departmental. Similarly, class teacher for section A, class teacher for section B, class teacher for section C. Okay, for one department, HOD will be always one. Class teacher will be many. For one class teacher will always be one. Subject teacher will be different. So parent will always one, but children can be more. So for each child record, the tree will contain only one parent, but each parent can have one or can have multiple records. It's called hierarchical database. It's called hierarchical database. Next database is network databases. Next database is network database. So the name suggested network database means the database which follows the network. You know, in today's generation, we just talk up the phone and we just say network is very low. We're not getting the network. There's a network issue. It's for child also use the same word. Mama, network issue. Network is not there. So network database means that follows the network data means the representation, T is missing, sorry. The representation of data here, like not C, it's a T is missing here. The representation of data in the form of nodes connected by links will be there. Okay, means this is data, 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 this is data. And if you connect them, it makes there is a network. So this is called network data model. This is called network data model. Okay. Here data is in the form of nodes connected by links, and this one network created, that's called network. Next is personal database. Next is personal database. It's personal, but if the name suggests, it's used for personal purpose. It's used for personal purpose. Okay, so it is basically designed for a single user. Suppose I want to create my own database. Okay, collecting storing data on the user systems. I want to create my own database. Okay. For example, as a housewife, I just want to create a database for my household things. Okay, I want to make one calendar type. I want to make billings of my milk and everything. That's personal database. Or personally, if I'm an entrepreneur, I'm at a small level. I just want to create my database. That's called personal database. Okay. Next is operational database. Operational database, it creates and updates the database in real time. It creates and updates the database in real time. It helps organization to increase and improve their efficiency. To check whether the operations are working properly. That's operational database. Okay. So it create the database and it updates and manipulates. It just check the database in real time, whether the database is working properly or not. We have created some data, we have saved our data, but after creating the database, we just want to check the authenticity, or just want to check whether our database is proper or not. So we'll check it in the real time. So operational database means just creates and updates the database in the real time. If you check the database in the real time, then you can understand what modification required, what is the issues, and what is the drawbacks, and what are the. So in this way, the organizations can understand the importance, and by this way they can increase or they can improve their efficiency. Next is enterprise database. Enterprise, you know, why the what you can understand. Enterprise means large organizations. Okay, enterprise, big companies. So enterprise database, large organization or enterprises use this database for managing a massive means big, large amount of data. Okay, if suppose a company have thousands of people or millions of people or employees, so how to manage them? So for large organization or large enterprises, then that database created is called enterprise database, because we are dealing with massive amount of data. So it helps organization to increase and improve their efficiency. It allows simultaneously access to users. Okay? So enterprise database, by the name, it's for large organization or large enterprises where we are dealing with massive amount of data. Okay? So this is the last. So in today's lecture, we have finished. We have understand the type of database. Okay. In the previous lecture, we have understood the introduction of database. What is database? What is definition? What is the history and important? In this particular lecture, we have understood the category of database, types of database. Okay. In the next lecture, we'll see the introduction of SQL. But our course is SQL database. So first we have understood the meaning of database. Now we will understand the meaning of SQL in the next lecture. So till that time, bye-bye. Take care. God bless. Thank you. Bye-bye.